Right, so in part 2, they've now changed a few things. So I'm just going to label the diagram again. I've got RA, RB, I've got the weight still acting at the center. So I know that this distance here is 0.4 and this distance here is 0.6. And then I also have a new force, this object that I've put, x meters from C. So I'm going to label the distance x and then do a down arrow that I call W, because I don't know what the magnitude of the weight is. And if that distance there is x, then this one that I'm labeling here must be 0.4 take away x. Okay, now what we've got to do is to work out the reaction at A. So what we do is take moments from the other point, which is B. Exactly as you would if you had numbers everywhere and not letters. So moments about B, I've got to do the W force, which is 1, add 0.4, take away x. So altogether that's 1.4 minus x. So all I did was to add these three values together. Times W. Okay, and that would be going this way, which is anti-clockwise, so I'm going to put a minus there. Then I've got the RA force, which is 1 meter away, and that's going clockwise. And then I've got the 40 force, which is anti-clockwise. Okay, equals 0 because it's in equilibrium. Right, all I have to do now is rearrange this so that it looks like the one they have in the question. So what I'm going to do is keep the RA where it is, because that's what I want to make the subject. And then I'm going to move the other things to the other side. So 0.6 times 40 is 24, becomes plus when I move it over. And also this very first term that I've written here becomes plus once I move it to the other side. And if I take out a minus and I put the W at the front, then the things in the brackets will switch around. Okay, so I've shown it. Then it says find a similar expression for the vertical force on the shelf at B. So again, we could take moments from A, or we could just resolve vertically. RA plus RB equals W add 40. So if I put my expression for RA here, plus RB equals W add 40. RB needs to be the subject, so I'll move everything else to the other side. I've got 40, take away 24, 16. I've got plus W WX and minus 1.4 W. So if I put the W minus 1.4 W together, I get minus 0.4 W, and I'm just taking the W out in a bracket. So that's your second reaction. And finally, in part 3, they're asking you what values of X will mean that the shelf does not tip up, and they've told you what value to use for W as well. Now, you know that so long as the reactions are positive or equal to 0, that means that the system will be balanced. If they are equal to 0, that means they'll be on the point of tilting, but they won't actually be tilting. So you must include equals to 0 as well. So I know that I can write these two inequalities. I need the reaction at A to be greater than or equal to 0, and I need the reaction at B to be greater than or equal to 0 in order for the shelf not to tip up. So put 200 in here for W and here as well. You then have 24, take away 200, x minus 1.4 has to be greater than or equal to 0, and also 16 plus 200, x minus 0.4 has to be greater than or equal to 0. And this is just a matter of rearranging the inequality. So when you do that, you end up with x less than or equal to 1.52 and x greater than or equal to 0.32. So x has to be in between and including those two values. So I'll just write that as one inequality. And that's your final answer.